manage those kind of applications for you. And then the third pillar, what I'm focusing on today, is the cloud applications, how you can make sure that whatever kind of cloud applications you're building, designing, to do that in the most secure fashion. What are the key challenges that I'm seeing typically in customer environments? First of all, it's the lack of visibility. So if I talk to customers that are adopting clouds, typically they're not just focusing on one cloud, they're adopting multiple clouds. They have basically no idea what's going on, what kind of services have been used, what kind of entities have been distributed worldwide in the cloud environment. And it gets more and more challenging the more cloud providers you're using. There are a ton of tools out there that give you the feeling of getting some kind of security when it comes to specific areas of the cloud, but there's no tool available that is basically focusing on, let's say, the full cloud solution stack that is available. And the other challenge that I'm seeing is that, most of the IT companies or customers are focusing on a non-agile operation. That means the development takes typically more until you get, let's say, the benefit of whatever you designed in your applications and bring this into market and getting the feedback loop. With the adoption of DevOps, it's a typically complete change of how you do that on a day-to-day basis. What we are approaching is we want to give you the possibility to secure the cloud and not focusing on a specific area. We focus on every resource. So we have an asset management that is focusing on making sure that whatever has been distributed in the cloud or provisioned is being configured as secure as possible. It's not violating any of your compliance requirements, configuration requirements. We're doing that at the full life cycle of the, let's say, workload that you're provisioning. So lifecycle means it starts already on the developer laptop when the application has been developed, so we can check it before it's actively deployed into the cloud. And we're focusing on any of the clouds. So the most famous one, like Microsoft Azure, AWS.
Andrea, just 1 second, please. We cannot see your screen. I don't know if you can hear me.
Okay, I can hear you. Yeah.
Okay, so we cannot hear your, we cannot see your screen. But did you click the go live button you have right there on top of the screen?
Yes, it's showing me live and recording.
Okay, that's great. So you also need to present. There is on the right vertical menu, there is a present button.
Yeah, click that.
Okay, and I'm gonna uncheck myself.
Do you see it now?
Yes.
Yeah. Should I start from scratch or how do we?
Yeah, because I didn't see anything at all.
Okay.
So yeah, please go ahead. Sorry. Okay,
No
I have
problem.
to jump on the other track.
No problem. Okay, let's start from the beginning. It looks like no one has seen my presentation, unfortunately. Hopefully this is now working. So yeah, welcome everyone to the Prisma Cloud Compute demonstration that I give you today. I'm focusing on a very specific part within the Prisma Cloud area. My name is Andreas Wilke. I'm a principal solution architect. I'm part of a specific team within Palo Alto Networks. If you're not familiar with Palo Alto Networks, it's basically the #1 cybersecurity company in the market. As you can see by the numbers, right? More than 85 of the Fortune 100 customers are using us. We are the #1 enterprise security company with more than 60,000 customers worldwide. The reason why we are so successful is because we're investing into basically every aspect of cybersecurity, which is a lot in today's world. So we are focusing on things like security enterprise, as you can see on the left side, which is more the traditional, let's say, firewall business, where we're focusing on your local data centers, hybrid infrastructures. But we also did a lot of investment into IoT, 5G, and endpoint protection. Then we also focus on creating the secure future, which I call the autonomous. security operations center. So we're focusing on basically analyzing all the threats, all the things that are happening there, and give you the possibility to give not only the detection capabilities, but also the full automated response and orchestration around security issues in the environment. Today, I'm focusing more on secure the cloud, and even in secure the cloud is a lot you need to focus on. We have those three pillars like secure access, SaaS, and public cloud. With secure access, I'm talking basically about how you can make sure that all your users within the company itself, if they're working in a home office today or if they're working on site, how they can basically access all the applications that you have running in the cloud. When we're focusing on SaaS applications, that's a typical challenge to make sure that those applications are being secured as best as possible and being used by the right audience and not having any affected files that have been used there. I'm focusing more on the cloud applications today, which is the right side. So how you can basically design, build, and deploy those kind of applications in the cloud. The typical challenges I see is, first of all, when I talk to customers, is they have basically no idea of what's going on in the cloud. So they don't have an idea of what are all those, let's say, virtual machines that are deployed there, containers, Kubernetes clusters, service mesh running in the cloud, all the firewalls, etc. They have no idea what they are being used for, and if they are being provisioned, if they are provisioned with a secure manner, and that it's not violating any of the compliance regulations. And then if you take a look at the cloud ecosystem itself, there are tons or millions of tools out there that give you, let's say, a key piece or a little part of the cloud that you might think you can secure better, but it's basically only a little fragmented piece out of the whole cloud story itself. And then the third challenge I'm seeing is that most of the companies didn't basically adopt the key principle of DevOps, which means of having iterative cycles and giving direct feedback if anything is not working as expected. And when you develop something as a developer, to get immediate feedback instead of waiting a half year until the new release is out, and maybe it's then too late and your competitors already have adopted that kind of feature that is missing. When we talk about securing the cloud, we're talking about those three key pillars, which is one of making sure that every resource in the cloud has been secured, making sure that it's not only your virtual machines, your containers, your data stores, etc. It's the full holistic picture to making sure that we're taking care about everything that has been provisioned into the cloud. And also the second, and which for me is the most important, is making sure that the whole life cycle of those resources has been protected. So the sooner the better, I would say, the shift left approach, making sure that already on the developer laptop, you are making sure that there are no security issues with the tools or the workload that you provision within the cloud. And then as a third one, we're focusing on protecting any cloud. So the big ones like Microsoft Azure, GCP, AWS, and Alibaba, making sure that those cloud can be managed from a single pane of glass. What we did as Palo Alto Networks, and you might have seen it, we've done a lot of acquisitions. One of them was the company Twistlock that I'm working for, which is focusing on a cloud workload protection platform. Those are the Gartner, let's say, marketing words that you see here. But basically, what we offer within Prisma Cloud is that we only have a single pane of glass where you can do cloud secure poster management and cloud workload protection platform within a single product, which makes your life really easy. As you can see, they basically bought the best of breed technologies in both of those ecosystems. So when we talk about cloud secure poster management, they've done an acquisition of Evident and Redlock, and on the cloud workload protection, it's PureSec, Twistlock, and Apareto that are being now integrated into a single stack, but also have the integration into the other areas of Palo Alto Networks. So we have an integration to PAN-OS, we have an integration to Cortex, how we can also making sure that whatever we're detecting, alerting you, will be fully automated. So that's the key vision here. Prisma Cloud itself is focusing on making sure whatever you've been provisioned in the cloud, that we are detecting that. So as you can see, We're using APIs to connect to those cloud environments. We're collecting all the entities, CIs that you have within the cloud environment. And then we're checking the configuration. Not only that, we're also taking a look at the flow logs within the cloud, making sure that there's no abnormal behavior of users. Let's say a user that typically is only creating EC2 instances in AWS, somehow is now starting to heavily delete them or reconfigure them, attaching a network device that shouldn't be affected. So we're doing the whole network analysis, and we also take a look at the vulnerabilities and activities that are going on within the cloud. So you can see on the right side, we have a lot of external connectors that we can use, as Prisma Cloud has basically been used to do the detection part. But when it comes to the remediation, typically a traditional system like CM tools, ticketing system, etc., are being used. What I'm focusing on today is a little bit more about the workload itself. So how we can better protect the workload. Why is this so important? Because when you take a look at the numbers of cloud adoption itself, containers, serverless, etc., it's basically an exploding ecosystem. And I'm always impressed when I'm seeing events like KubeCon or Cloud Native Con, where basically more and more customers are coming. I think it's the biggest event now where customers focusing on. And you can see by the numbers of that 8 of 10 enterprise applications are now cloud native in today's enterprise world. Containers themselves, I don't have to explain what they are. They've gone really, really mainstream. They've been used mainly everywhere in every kind of application. If it's not containers, it might be already serverless applications that you're using. And one of the names you cannot avoid when you talk about containers in cloud is Kubernetes, right? Kubernetes is basically the de facto standard when it comes to cloud. A whole ecosystem has been created around this. And this is basically also the challenge that I see with the customers when they take a look at this ecosystem around Kubernetes, which has been named the cloud native landscape, and it's been changing on a daily frequent, right? There, you see new platforms coming on the market every day. You see new security tools, service mesh proxies, API gateways, databases you can use, a ton of things you need to take care of. Basically, you give the developers a huge menu of technologies they can select to start developing their applications, but you also need to make sure that whatever has been chosen here can be managed by a single pane of glass. So what we are focusing on here is how all of those technologies, all of those virtual machines, the containers, the serverless can be protected, and how can we make sure that this is happening as soon as possible within the life cycle of those kind of workloads that we're seeing in customer environments. So what we're doing is we're focusing on the 3 pillars here when it comes to make your life as easy as possible. Number 1 is automation. So automation is a key principle, making sure that within the container ecosystem, serverless ecosystem, we're not talking about hundreds of virtual machines or thousands of virtual machines. We're talking about 10,000s of containers and maybe millions of serverless applications that you need to take care of. If you try to do that with pure manpower, that's nearly impossible. So key topics should be focusing on how you can automate as much as possible of those areas been shown here, like vulnerability management, compliance, firewalling, runtime defense, access control, CI/CD integration. Those are big topics where we can focus on. But key focus should be automation. But before you do automation, you need to get the visibility. So you need to understand what is really going on in my Kubernetes cluster. What is going on in the container itself? What kind of processes are there start? File system activity. And when you have that visibility, you can start to take a look at how you can prevent anything that shouldn't be run in my container, serverless infrastructure, whatever it is. And then we designed a very simple product that you can use on-premise or within the cloud. It's a graphical user interface where you can basically design all the policies around your host, your containers, your serverless applications. We're updating it with a SaaS service that we call Intelligence Stream, where we have all the malware information, black IP addresses, vulnerability information that we can detect in those systems. You can fully automate that because it's an API-driven console or REST API. You can integrate it into user and group management, and we can alert any kind of external system as soon as you've provisioned it. The console itself, it's a container, so you can spin it up in a Kubernetes cluster, in a Swarm cluster, on a dedicated node. So it's very easy and fast to get it up and running. And then on the next side, what you're doing is you're basically provisioning it into your container environment. So we have a container defender that can be run in a Kubernetes cluster, making sure that everything that runs in your container infrastructure is being protected. We have that also for host OS, so we can protect the same way how we protect containers also on the host side, making sure they're compliant, they're fulfilling all the sys benchmarks that you might need to fulfill for containers, for Kubernetes, that their hardening guides have been fulfilled, and then maybe no containers running on a host that is not protected, or also any kind of host that your containers are connected to, your database source, application services, and you can run, you can have the same capabilities here enabled as well. And then on the right side, as I said, we also have that for your serverless functions. So even the serverless functions can be protected, even if they don't have, let's say, a real runtime environment. We can integrate into the serverless function, making sure when the serverless function has been executed, it's been protected, and is not starting in a malicious code, not trying to connect to any not known DNS resolutions doing, or any network and port connection that is normally not allowed. And as soon as you have that deployed, we can start to integrate it into your CI/CD pipeline. I can show you how it looks like from a developer perspective, making sure that every repository and registry of your containers and images and serverless function is being protected before it's been really actively used inside a production environment. You can use that as a SaaS solution, so it's basically managed by us. We basically update then the console for you within Prisma Cloud tenant itself, or you manage it by yourself. So you are responsible of updating the two components, the console and the Defender technology. I would like to use the last 10 minutes focusing on what the shift left approach really means is, and why we are doing it. If you ask me, it's basically to give you a lot of, let's say, gateways between the different phases that you have in a typical DevOps approach. So DevOps, it means that more and more of the operational stuff is being going into the hand of a developer. So as soon as a developer is writing code and is committing it, it's automatically going through all of those integration tests, functional tests, etc., and also into the complete automated deployment into your production environment. But there are a lot of things you can do before that happens, and before the container, the serverless function, or the nodes themselves are actively running. So first of all, we can start to scan the code itself. Just to show you how it looks like, if I go here quickly in an environment, we have the code scan capabilities. I have a code repository. You will find it on GitHub at Automate Cloud, my tweet app. You can use it on your side. And as you can see, I'm using a Python application that has been affected by the requirements that I'm using here. And I can see exactly what kind of vulnerabilities have been detected and what kind of activity do I need to do from the code repository to make sure that this has been fixed before it's being packaged into a serverless function or a container itself. So that is what we offer here. We scan from GitHub itself. Every time when a push has been sent, we automatically scan the new code. If it's been affected, then we alert you, if you like that, to the developers themselves. So every time when they're developing something, they can check out the code on Git. Then they can basically build the containers locally on the system themselves, and then we can scan this container already. Is it been affected by any vulnerabilities? And this looks like, if you take a look at an IDE like I have here, like Visual Studio Code, I'm developing this Python example application that you find on the public Git repository I've shown you, where I'm doing not magic. It's just a GIF application that is showing different GIFs within the browser, and it's running within the container on the host, if you would like to run it on the host, also possible, and changing the GIFs files. What I'm doing here is I'm building my container, and all the containers today are being built with Docker files. So you have to define a base layer that's been used. You can define the maintainer, which is me. I have some alert labelings been enabled, so that is something that we can read out and then inform the developer if something is going on with this Docker file, maybe in the CI pipeline. I'm doing not magical things. I'm just using Flask to make sure that this application is up and running. I'm exposing it on the port, and then I'm defining the entry point to make sure that this application is running as soon as the containers get started. I also have a deployment file defined here, which is a Kubernetes file. You can use Kubernetes files, you can use Terraform files, CloudFormation templates in this scenario. I also need to make sure that this, whatever kind is being defined outside of the container itself, is also not violating any of my compliance rules, right? So, for example, there's some things like this container is been managed as a privileged container. Maybe you don't want to have that in your running production environment, because privileged containers basically give you access to everything in the infrastructure. And if a hacker is attacking this kind of container here, he has basically more or less immediately access to the underlying host. What I've done here is, as an easy integration, is every time when I'm building this container, we're using a little binary. It's called the twist CLI. From a historical view, twistlog, it's still called twist CLI, where I'm scanning in the images against the console that you're seeing, against the policies that I'm defining centrally, making sure that this image is not being affected by any vulnerabilities. But I'm also scanning the deployment files. So I'm doing an infrastructure code scanning here, making sure that the Kubernetes file itself is not affected by any compliance issues. And if you take a look at the output of the bash script that I'm running here, you can see, as a developer, I'm getting all the information that I need. After I finish the build of the container, I can see, for example, what kind of vulnerabilities I'm affected from, what is the severity level, what is the CVSS information, which package, which version has been found, which should I focus on, when has this been published. This is really important when it comes to policies. So maybe you want to define grace policies for your developers so they can skip or the new CVEs are ignored for a week until it's been blocking your pipeline, whatever you have defined it within those pipeline itself. And you can see at the same time, you're also doing the compliance checks. I have the sys benchmark for Docker being integrated. I've created a lot of, let's say, custom things. I'm checking if a specific user exists within this container. I'm checking if a file exists, if the permission has been configured correctly, that the image itself should run with a non-root user. And now you can see the problem that exists. Even if I define that the container to use a specific user instead of root, it doesn't protect me against that someone is going into the deployment file, and that is what I'm checking here. So the Kubernetes YAML file, which has been configured to run as a root user, and is also configured to run as a privileged user. And I have my custom compliance check here configured as well to check for a specific port. And this has been violated. So you can see from a CI perspective, if I'm triggering the same in my CI tool, it would fail. And this is basically the next step you do, right? Whenever the developer says, okay, I didn't find anything on my local laptop, I'm committing it to my Git repository, it's triggering my pipeline, let's say a CI pipeline like Azure DevOps, then you would see the same effect in Azure DevOps. But here I then have the effect that my pipeline itself will fail. So if I'm going back here, 1 second. Then you will see that the twist CLI did throw an exit code because the scan itself did fail, and which will basically stop my deployment process as well. So I'm not able to deploy this specific container when it's been affected by a vulnerability. And the same is also that I'm doing here. The same twist CLI scan has been triggered within my pipeline tool to making sure I can influence it, defining policies, let it pass or let it fail, depending on what kind of violation we've detected. And then it's continuously like that, right? So we can integrate the registry, repositories, we can define trusted images, so you can create a list of images that have been seen as trusted images. We can check the deployment file if, let's say, you're separating between the CI/CD process. We have an admission controller using Open Policy Agent, which is basically the last hurdle to see if anything has been affected before the cluster itself is triggering that. And when the cluster is running, we have the runtime protection. It would take too long to go into details, but just to make you aware of, we're basically analyzing the full behavior of all of your containers. As you can see from cluster level, we go really deep into the containers themselves analyze them, see what they're doing from a runtime perspective, what processes are the triggering network behavior file system, and if anything is violated during the runtime, we can also stop that and actively block that within a container themselves. I think we are at the end of the presentation. I'm sorry that there were so many technical challenges at the beginning. Feel free to visit our booth if there are any questions. I'm happy to answer them. Thanks a lot for your time.